Quadratic functions.
Okay, so we've met again to talk about quadratic function and our elective math concept. Quadratic functions. Okay, what is the quadratic function? Take note that a quadratic function is under a polynomial function, or let me say a trinomial function, for instance, because trinomial functions have three terms and quadratic function also has three basic terms. But quadratic functions are functions that have constants, and the constants serve as the coefficient of x squared, s, and the constant number itself. So what happens is that with a quadratic function, the highest degree we can go is squared or 2. So we can have functions like 3. That is when we are leading to polynomial functions and other stuff. But when we take quadratic function, the highest degree we can go is what? Is 3. So now it is represented as ax squared plus bx plus c, where a is the coefficient of x squared, where b is the coefficient of x, and c is the constant value itself. So this one makes a quadratic equation or a quadratic function. Okay, so if you have y is equal to ax squared plus bx plus c, it is an equation. It is a quadratic equation. If you have f of x is equal to ax squared plus bx plus c, it is a quadratic function. So this is just, by the way, the difference between the equation and the function. Okay, so now what happens is that the x values is same as the roots. So anytime you have a quadratic equation, you can find the values of the x. And the values of the x, because it is squared, you get two roots. So you can get maybe x is equal to c, or maybe x is equal to e. These values you get for the x are what we call the roots of the quadratic equation. The roots of the quadratic equation. And these roots will satisfy the equation given in different forms, either a factor theorem or a remainder theorem. So these roots will rather satisfy the equation, either a factor theorem or a remainder theorem. And we know that the remainder theorem is when you have maybe f of x, maybe x is equal to this c, so f of c is equal to what? R, a certain value r, that is the remainder theorem. And the factor theorem is f of x will always be equal to what? Equal to 0. That becomes the factor theorem. Now there are three common ways of finding the roots of a quadratic function or a quadratic equation. So anytime you have a quadratic function, there are three common ways of finding the roots. One, by factorization. Two, you can find the quadratic equation 2 by method of completing the square. And 3, by the quadratic equation formula. Okay, so these are ways we can find the roots of a quadratic equation. Quickly, let's go to the factorization, because I want us to tackle the method of completing the square. So with factorization, it is very simple. So if you have ax squared plus bx plus c, and we say, let's say it's equal to 0, and you're asked to find the root of this quadratic function using factorization, what happens is that you always multiply the coefficient of the a by the constant itself, so a times c, and you find factors of ac. So you find the factors of ac. Now when you get the factors of ac, what happens is that when you find the factors of ac, you can simply go on, and let's say the factors of AC is what? A and C. So if the factors of AC is A and C, then we can say that ax squared plus cx plus as plus b is equal to 0. So then the factors of a and c are this. We expand the equation like this. So therefore the cx plus the ax will be equal to what? The bx. The cx plus the ax should be equal to what? The bx. And when you do this, you can have ax squared plus ax plus cx plus c is equal to 0. So you can have ax squared, you can have here ax into brackets, factorizing ax as x plus 1 plus, you can also have factorize c out here, you get x plus 1. So anytime you do that, you must make sure that the factor in the bracket should be equal. So you get the ones outside becomes ax plus c in bracket x plus 1 is equal to 0. So ax plus c will now be equal to 0, which will give you x as c minus c on a, and x plus 1 equal to 0, which will give you x equal to minus 1. Okay. Now, this is how you go through the factorization method. I know you know that already, no questions you can solve under this, but this video I want us to focus on the completing the square. Now the completing the square is, we use completing square for some quadratic equation which cannot easily be factorized, or which cannot easily be factorized by the factorization method, or we cannot easily find the root by using the factorization method. So we have to use what? The method of completing the square, or the almighty formula, or the almighty formula, which is the quadratic equation formula. So this video, or this lesson, I want us to focus on the completing the square. The next lesson, you do the quadratic equation formula. Okay. Now we have ax squared plus bx plus c. With method of completing square, the first step we go is that we should make the coefficient of the x squared to be 1. So the first step is that make the coefficient of x squared as 1. So that's the first step. You make the coefficient of the x squared as 1. So to make that ax squared plus bx plus c, how do you do? I have to divide both sides by a, so it is equal to 0. So this one cancels this. So we get x squared plus bx over a plus c on a, which is equal to 0. Now after you do this, multiply, you have to multiply the coefficient of x, so which is bracket b on a. So multiply the coefficient of the x, which is b on a, by half. By half. So this is the process of the method of completing square. Okay. Now when you do that, what do you get? So b on a multiplied by half, you get what? B on 2a. Now when you are done with that, you add what you get, the final answer you get here, we add b on 2a, sorry, you add and subtract b on 2a to the equation, to the quadratic equation. So what it means here is that now we can say x squared plus bx on a. I get, so we add b on 2a to the equation, which is what? Plus b on 2a. Sorry, after that you have to square it. So the b on 2a have to be squared. After you multiply it by half, you have to square it. Okay, so when you square it, you get plus b on 2a all squared. So let's take the c on a to the other side of the equation, which becomes minus b on a. So we add or subtract. When you subtract it here, the next one you subtract can become a product here. So okay, let me go straight forward. Minus b on 3a all squared plus c on a, which is equal to 0. So from there you can get x squared plus bx on a plus b on 2a all squared plus b on 2a all squared minus, equal to minus b on a plus b on 2a all squared. So you brought this minus b on 2a to the other side of the equation. That's why it's what? It is plus. Now when you get here, what you can do is that this whole term here can be now simplified as x can be now simplified into its simplest term as x plus b on 2a all squared. X plus b on 2a all squared, which is equal to minus c on a plus b on 2a all squared. Okay, and this is what we call the method of completing square. The method of completing the square. Let's take an example. One example. So, example: find the roots of this quadratic equation: x squared plus 4x plus 1 is equal to 0. X squared plus 4x plus 1 is equal to 0. So you have to find the root of this equation using completing square. So using completing the square. Using completing the square. Okay. Now the first test is that we should make the coefficient of x squared to be 1, but in this case it is already 1, so we maintain it. Now the second rule says that multiply the coefficient of the x by what? Half. What is the coefficient of x here? It is 4. So the first step is x plus 1 is equal to 0. The coefficient of x is already 1, so we maintain it. We are multiplying the coefficient of the x by half. What is the coefficient of x? Which is 4. So therefore 4 times half will give you what? 2. After you multiply it by half, you have to square it. So we square the 2. I get it. So we get 2, and we square the 2. Now this thing we square, you have to add it and you have to subtract it to the main quadratic equation. So we add it to subtract to the main, so x squared plus 4x plus 2 squared minus 2 squared plus the constant 1 is equal to 0. Can you get it? Okay. So now you have to pick one of them and the constant at the other side of the equation. So you get x squared plus 4x plus 2 squared is equal to minus 1, and this one down plus 2 all squared. And that gives what? So when you do this, you are getting x here, x minus 2 all squared, x minus 2 all squared, which is equal to minus 1 plus 2 minus 1 plus 4, which here it will be minus 1 plus 4, which is equal to what? 3. So this one will give you what? We'll give it 3 straightforward. Okay. So what happened here is that we can now take the square root of both of them. So you take the square root, this will cancel this. So we get x minus 2 is equal to what? Plus or minus root of 3. Plus or minus root of 3. So therefore x is equal to 2 plus or minus root of 3. And we know that every quadratic equation has two roots. Every quadratic equation has 2 roots. So therefore the x1 will become what? 2 plus root of 3. And the x2 will become 2 minus what? Root of 3. 2 minus what? Root of 3. And that will give you what? x1, if you do 2 plus root of 3, you'll be getting 3.73. And this one will give you 1.73 x2. I get it. Now try this question in the house. Example 2. 2x squared minus 3x minus 3 is equal to 0. When you do this, the answer you get x equal to 3 on 4 plus or minus root of 33 on 16. So try this example in the house. Thank you very much.